Welcome to the first video of a series that we have prepared to present to you the key features of the SORRIR project using our demonstrator. The demonstrator is an application that is built upon the SORRIR framework, which encapsulates a state machine and is built via Node.js. It has an inbuilt integration with the Kubernetes cluster, and everything that we show with the demonstrator is run on our local Kubernetes cluster. And all the scenarios that are listed in here are using it as well. Our use case is a smart parking garage, which has a web integration and a reservation system which can be interacted with via a web interface as well as on-site reservation, just like a regular parking garage. All accounts are tied to license plates, and we use optical plate recognition at the entry and exit barriers to recognize cars and corresponding accounts. All parking spaces are arranged in grids, and we have sensors to follow around cars within the smart parking garage, so cars can always be located. In this slide, we have the architecture of some different components that we use to implement the smart parking garage. And on the left side, we start with the external components, which are not real components, but rather mimic interaction of either the user or the car with the smart parking garage. At the center of the whole smart parking garage is the parking management system, which not only connects all the different components together, but also holds data about reservations and the structure of the smart parking garage itself. We have a web interface that can be used for offsite reservations, and all requests are forwarded to the parking management system to then be processed and stored within it. Also, requests for payment will be forwarded to the payment service provider to be then handled by online payment services. On the top side, we have the smart entry console, which is connected to a camera and a barrier and forms the smart entry, which handles every car that tries to enter the smart parking garage. The camera itself is connected to the plate recognition service, so it forwards all the image data that it collects, and the plate recognition service then will use optical character recognition to find out the license plate which is connected to it. Afterwards, the information is sent to the accounting service, which will then retrieve the account data. If everything has went all right, the barrier will then open and will let the car through. Similarly, the smart exit console has also a camera and a barrier connected and works the same way, just on the exiting side of the smart parking garage. So additionally, it will handle requests for payments. The remaining components on the bottom right are parking space sensors, which every parking space has one of. As you can see, we only have 4 of them, which means we, in this case, only have a small grid for demonstration purposes, which is 2 times 2. In the following, I will show you the demonstrator front end, which we have implemented to make interaction with the demonstrator easier. Here we can see the user interface that we use to interact with the demonstrator. All the components are listed here and are also clickable. So if you click, for example, here, as stated, the PMS, then you can see all its internal states. The PMS stores how big the smart parking garage is, and it also stores the statuses of its parking spaces. So, for example, here, which reservations are there for a specific parking space, if it's occupied, if it has other properties. Other data that is shown here is idle, which means it's currently not doing anything. And whenever it changes its state machine state would appear here. Below that, it says with 2 underscores, OK. This is the internally monitored state if it's available, if it's online, and if it can take part in the whole state machine. If I would kill all the components, for example, like I'm doing here, then it would jump to unreachable, which would indicate that it's currently not available. When I restart the component, it will jump back to OK, and it can now take part in the rest of the logic. Now, let's go through a typical run-through here of the demonstrator use case. The first thing that a user would do would be to do a reservation online before arriving at the smart parking garage. So in this case, from the web service, an event would be sent to the parking management system with a request for a reservation. And let me just copy the parameters in here. It would state which account this is for and also from when to when. Now, if I send this event here, We see in the internal state that the reservation has been updated and that one of the spots now holds this reservation. So when the user will arrive at the smart parking garage, it will have this reservation available. Now let's jump to some point in the future where the user arrives at the smart parking garage. They would arrive at the smart entry console, and now the barrier and all the sensors here would detect that a car has arrived. So here at the port from the car simulator, it would state that a car has been detected. And this also has some internal data which includes a timestamp. If we send this here, we see that the smart entry console is now waiting for something in the next state. It's waiting for the camera module to find out which license plate the car has. Now we feed the camera module with the data that is needed for this. In reality, this would be some kind of image, but in here it is just a string to make it a little bit easier to interact with. Once we send this here, we can see that the arrival is now completed. Since the feed image data triggered an interaction of the camera module with the plate recognition service, which in turn informed the SEC that a specific license plate has arrived, which would trigger communication with the accounting system, which then would say, this account has arrived here, let it through. Now, since its arrival completed, all we have to do is tell that the car has run through, which we can do by sending a car detection ended event, which means the car is within the smart parking garage. Now, to indicate that the car has arrived at the parking space, we tell the sensor that it senses a car and it will jump to occupied, which means the car has arrived and the arrival use case is finished. Now, we basically do the same thing backwards. The car is within the parking garage and leaves it. So what we do is we tell the sensor that it's now empty since the car has left it. And on the other hand, tell the smart exit console that the car has now arrived here. The timestamp now here is 1 hour later because the reservation was for 1 hour and the car just has left it. We send this event here and now it will in turn jump to waiting for camera module, since both on arrival and on leaving, we need to detect the plate to know which account this is all about. We send the data to the camera module, and afterwards we see the leaving is completed, since this triggered a whole cascade of events again. It triggered the same cascade that we had before in connection with the accounting system, but additionally, it will also trigger the payment, since the smart exit console will communicate with the PMS, but also with the payment service provider, which will then trigger a payment. Now, since the payment has been completed, the car can leave, and all we have to do now again is tell that the car has left with a car detection ended event, and it jumps back to idle. So the user has requested a reservation, has entered the smart parking garage, has been there for some time, and has left it again. So this is how our smart parking garage works.